Hi guys, hope you are having a great time in this e-learning week, and welcome to watch this video of discussion group in CS1010. So this week we are going to talk about common mistakes as well as some group practice when you write your C programming language. Let's get started with this very romantic story. So there was this guy who fell in love with this girl, and this guy was so romantic that he decided to write a program for the girl. So somewhere in that program, the guy wanted to print out an infinite number of "I love you" on the screen. So the guy came up with this: for I equals 0, I less than a very huge number, I plus plus, and print "I love you." But it just so happened that the guy didn't take CS1010, and he made a mistake. He put one extra semicolon here. So what this means is the computer will think that the block of this for loop is nothing. So for infinite number of times, the computer do nothing. So this is an infinite loop. It turned out that the computer just hang there in the infinite loop and never print anything out. So you know the rest, you know the results of the story, right? It was romantic, but now it's tragic. Yeah. So today, again, we are going to talk about a lot of examples and common mistakes, good practice. Why is that? By looking at examples, I hope you can understand C better and to know better, to know its syntax, to know its logic flow better. Okay? And for the common mistakes, I hope they can save you from wasting too much time on unnecessary debugging. For good practice, I hope you could write better code, easier to understand, easier to read, easier to debug. Okay, so let's talk about some common mistakes first. What are the mistakes? So basically 3 types. So the first type is compilation error, which means, for example, you make some syntax error, so the program doesn't get compiled. When you compile the program, you have errors or warnings from your compiler, so your program cannot run. How about runtime error? Runtime error is like you have no problem compiling it, but when you run it, you may get into trouble. For example, division by 0. Sometimes the variable you put under the the variable may be 0, yeah, because the value keeps changing, right? Sometimes you can get division by 0, so it will throw runtime error. Of course, there are unexpected results, which means your logic is not clear, your logic is not correct, so your program can run, no runtime error, no compilation error, but the result is not what you wanted. So you may want to avoid some common logic error as well. All right, let's get started with the very first one. So as we can see just now, the tragic story, right? So it's misplaced symbols. Let's have a look at the example. We have a bunch of examples here. Vim, yeah. So you see, one common error here is you put a semicolon after the for loop or the while loop. This will tell the system, it will tell your compiler that the body of your loop is nothing. So it will forever hang here in this infinite loop. Right? This is one error. Another error, see here, this documentation, this line here. It is very good that you can have documents, that you have descriptions that before your function, but when you use this symbol, remember to close it. So in this case, there's no closing of this command. So basically, all the things that are after this symbol are treated as commands. So this function will not be able to get compiled. This part will be commands. Okay, so just take care of this. All right, that's the first common mistake. Next, I believe you have just learned the switch case constructs in your program. Let's see one example. Okay, basically for switch case, right? You switch on some value. So depending on the value of the variable, you jump to certain cases. But the key point here is for switch and case, for example, you jump into certain case, you are not running that case only. In fact, you are running all the cases that are after it. For example, you jump to case 2, you are not running this block only. You're actually running every block that is after case 2. So if you want to run case 2 only, you should put a break at the end of this case 2 block. Yeah? Just bear in mind. So just remember, whenever you have switch case, you should have break. Just remember this sentence. Whenever you have switch, you should have break. Alright? This will save you from trouble, especially when you have a huge number of cases where you don't know what happens, what goes wrong. Okay? That's a mistake too. Next is the if-else mismatch. Let's say what do I mean by mismatch? Mismatch. Okay? Let's see here. In this program, I have A and B two variables. I want to have a if-else case depending on the value of A. So you see, if A equals to 0, I want to do something here. Else, if A is not 0, I will just print, oh, A is not equal to 0. Okay? And of course, if A equals 0, I will jump here. I will say I will look at B. Okay, if B equals 0, I will print B is equal to 0. Okay? So if I run this program now, A equals to 0, it will jump here, and then it will do nothing because B is not 0. All right. So let's run this. Just try to run it. So GCC. So if you compile your program, right, you should use wall with all warnings. But here, for the demonstration purpose, I will just keep it simple. I will just GCC mismatch. Okay. I will run it. Yeah. Oh, it says A is not equal to 0. Let's see what happens. See, this line is printed A is not equal to 0. How come? I said A is 0, right? So how come it jumped to this else? The problem here is the else and if are mismatched. So I mean, this else and this if is mismatched. Just remember that the else only pairs with the closest if that is not paired with an else. Okay? So for this thing, right? This if is the closest if that is not currently paired with an else. Okay? So this if doesn't have an else and is closest to this. So in this case, this else will be paired with this. So which means B equals to 0, it does this. If B is not equal to 0, it will jump here, which explains why this thing got printed. So how to solve this problem? Very simple. You just break the ties between this if and this else. So you just do this, bracket. You create a new block. Okay? So basically, if A equals 0, it will jump to this block, and this else will never ever be paired with this if because they are in entirely different levels. This is one level down, right? One level further, it belongs to this. And so if A equals 0, this block, else this block. Yeah, let's run again. Yeah, you see, nothing is printed out. That's correct. Okay, let's move on. Mistakes number 4, implied typecasting. Let's have a look at this example. It's called type.c. Okay, so I have two integers. I want to let I divide j and assign it to m. But m is a float. I want to get a float. I want to get some decimal points, but obviously I cannot because I and j are integers. If I divide by them, it's integer division. I only get integers. So what is recommended, right? What is the correct thing to do is whenever you are using different types of variables, You just cast them before you do the computation. Yeah, like this. So let's compile it. Sorry, GCC. Yeah, you see, it's correct. So the next one I'm going to talk about is the variable initialization. Let's have a look at the example here. So if you read these lines, I believe you can find there are some mistakes, and in fact, very common mistakes. So you see, the first thing is you define a variable, but you didn't initialize its initial value, so you just use it. So this is wrong. You may think that this is so obvious that this mistake you never make. However, just bear in mind that when a program is very long, when the function is very long, you may forget. For example, if this is a sum and you want to sum up a few numbers in the subsequent steps, you have an int sum and then you use it, you forgot to initialize it. That's one scenario where you might forgot to initialize it. All right? And the second mistake here is you forgot, you have unnecessary initialization. For example, I equals to 100. Immediately after this line, you scan a new input and assign it to I. So unnecessary initialization, another mistake. I believe you have found the third mistake here, the I, right? The assignment. So it's missing an ampersand here. So whenever you scan an integer, a number, yeah, a float, a double, a number, anyway, so you should use ampersand sign here, so which is this sign, okay? Yeah, write it like this. Okay, so yeah, so these are the three very common mistakes about variable initialization. Yeah, let's move on. The next one is the misorder of your operations. Let's have a look at this example, order.c. Okay, so we have a function a, b, and c. Oh, I will sum the three numbers together. Okay, so just ignore this comment for now, just ignore it. So in the main function, what we need to do is I want to sum, I call this sum, right? This is a function. I pass in three numbers into it, and each of the number is a function call. It's returned by a function call. So in the sum, I'll call A. A will print this character and return 1. B will print this character and return 2. Similarly, C print C character and return 3. So obviously, I have 1, 2, 3 here. I will get a 6. But I want to know the sequence of the printing. So is A printed first? Is this character printed first? Is this function called first and then print first? Or is B called first? And so this B is printed first. Let's just run this. So GCC order a.out, sorry, a.out. Yeah, CBA. Oh, let's look at the program again. So it seems that this function is called first and then print C first. Followed by this. So the point here is, if you make function calls like this, there's no guarantee that which function will be called first. It's different from compiler to compiler. Yeah. So, but of course the return value is confirmed. Which function is called first, the return value doesn't change. So you can always print a 6 here. But the sequence of which of the function calls made here is not guaranteed. So if you want to guarantee a certain sequence of output here, you should split to different lines. For example, I have int I equals to A, int J equals to B, int K equals to C. Of course, A, B, C are function calls, okay? So in that case, it will be guaranteed that the function calls will be A, B, C. All right, so that's the order of function calls. Just bear that in mind. Another thing is the precedence of the operators. Yeah. So let's see what your lecture notes have told you about. Here you can see these are precedents of these operators by descending sequence. So of course the parenthesis is of utmost priority, so everything covered by parenthesis will be run first, followed by these. And these are some other operators. Okay, so just have a look at them and try to remember what are these, what are orders of these operators, so that in a long arithmetic expression function, you are able to identify which one is executed first. It is also recommended that if the arithmetic expression is so long, for example here is so long, it's very confusing because you have too many operators. It's very hard to decide which one is executed first. In this case, simply put brackets. Wrap the part you want to compute first with brackets. For example, I want to wrap this part as bracket, or if I want to compute this part first, I will wrap this with bracket, so that the order will always be guaranteed. So just help yourself with these extra brackets. There's nothing wrong, and also it helps you to make your order much more clear. What does it mean? Let's look at this example. As you learned in your lecture, right? The floating numbers and doubles are not stored in the memory. They are not stored the same as you assign them. They're stored as base and exponential parts. And if the base is too long, they just trim it. They can't store everything. So here I have two floats and I assign them, and I want to see if b minus a is exactly this value, which is I assign here, which is exactly this. Yeah. So I do this. Of course, this is not expected to be equal because the representation will be different from here. So it's very likely, it's expected to be here, which is not equal to this thing. Then, if the floating number is like this, how do you compare it? For example, I have float A, float B, but they may be represented differently. I assign them same. During the competition, they happen to be the same value, but they are represented differently. So how do I compare? So one way to compare is I minus them and I see whether it's less than the minimum difference, which is specified here. So if they are less, if the difference is less than the minimum difference that I can accept, I can tolerate, then I will say, okay, they are equal. If it is larger than the minimum difference that I can tolerate, then it's not equal. What is the minimum difference that I can tolerate? This thing is typically given in the question. Yeah, so you don't need to worry about it. Let's try to run this. Our GCC float.c out. See, not equal to this one and not. So basically, let's go back to the program and see where are these lines. So basically, the difference is not exactly the difference that we assigned, so it's not equal to, okay? And the difference, of course, is larger than the minimum difference we can tolerate because they are different numbers. Yeah. This is this mistake. Oops, sorry. Yeah, let's move on to the next. Mistake number 8 is variable scope. This is a very important one. Let's go. Okay, let's have a look at this. This program is comprised of several examples. So let's look at them one by one. So let's say in this block of for loop, right? I initialize this p variable. Every time I go into this, I print it out. Okay, and then after the block, I still want to use p. Can I use it? The answer is no, because where p is initialized is the block itself. After this block, the p is invalid anymore. So if you want to use P outside this block where it was initialized, it was defined, it was declared, outside where it was declared, you will get an error which is undefined identifier. So the P is undefined currently because it's already outside of its block. Okay. Similarly, in this if, see I equals 0, right? I will go into this. I have a J here, but if I want to print the J outside of this block, is invalid also, because where J was declared is where J will be valid. Outside this block, the scope doesn't apply anymore, so J will be undeclared. Let's try to compile. You will get, so GCC, all warnings, go. Oops, you see, in the function main, P is undeclared. And ignore this for now. J is also undeclared. Okay? So basically, outside of this, so basically this P, the scope is only valid here. After this block is invalid. So cannot do this. J is initialized in this block. After this block, J is invalid. It doesn't exist anymore. So you cannot do this as well. Okay, let's have a look at this. How about, I have an I here, right? I equals 0. But in this block itself, I initialize a new I. Well, this is possible because this is a new block. Inside this block, you can initialize the variable. But this I here, if you initialize it this way, the I will override the I that is outside, which is here. Which means if you refer to I in the future, in the following, the I will be this I, this new I in this new block. Okay? What happens to the I outside? It doesn't change. It's just that it's overridden. Its name is taken by someone else. Okay? So let's go through these 3 lines. So inside this block, if I print inside the if before a new I is initialized, I is this. Basically, at this point of time, this I was this variable outside the if loop. Oh, sorry, if block. But after initialization, this I override the initial I. So at this time, this I will be 3. How about after the scope? After the scope is over, this I is destroyed, doesn't exist anymore. So if I refer to I here, this I will be this I, so it's 0. So before a new I, the old Y, this one should be 0. And after you initialize new one, the outside one is overridden. So basically it borrows the name, so I, it becomes 3. Then after it, the new I is not valid anymore because its scope is here in the block. This new I is not valid anymore. So outside the if, the I will be 0 again. Okay, let's try to do this. GCC scope. Okay. See, inside the first if, before the new I is 0. Inside the if, I will be 3. That's when we initialize a new I. But after this if block, the new I is destroyed. So the initial, when we refer to I, we'll go back to the initial I. Okay, sorry again. All right, so mistake number 8. Let's move on. So the next one is it's like you cannot change a variable's value more than once in the same line. So for example, if you don't know the difference, for example, you don't know the difference between A++, plus A, so you want to do some experiment like this. Sorry about here. Okay. You want to do something like this. I print 3 integers, A++. Yeah, this is dangerous. And because the three functions, right? Their order doesn't. It's not guaranteed which one runs first, which one runs second, and it's different from compiler to compiler. So don't ever change a variable's value twice in the same line. So if you want to do experiment like this, just write them in 3 lines and assign them to different variables and print out the variables and see how it works. Okay? Next, check for equality. Let's have a look at the equal.c. Okay, so I have x equals to 5, then x equals to 6. Okay, I want to say if x equals to 6, I will print this. Otherwise, I print nothing. And here, if x 0 less than x 0 less than 5, I want to write something like this. So if x equals to 12, right, then this line will not is not expected to be executed because 12 actually is too large. So this line will not be printed. This is will not going to be printed as well, right, as we expected. Then for this line, it will be printed because x is 12, right? Let's see whether it works. Okay, CC equal. Oh, it doesn't work. It prints everything. Let's look at. Yeah, I believe you have already found a mistake, right? This thing, you are assigning x to 6. So this is assigning. If you want to compare, you should use double equal. And for this, of course, how the compiler interpret it is like this. So it will see whether x less than x, sorry, 0 less than x. X is 12, right? Then 0 less than x is true. So true value will be 1. So this will return a 1. Then 1 less than 5, of course, is true. So it will print this. So if you write something like this, it's always executed, no matter what the value of x is. Yeah. Even if this equals to false, false is 0, right? So this part is either true or false. So it's either 0 or 1. And both 0 or 1 are less than 5. So this thing is always executed. And this is correct as we expected. So the best way to write equal, right? So if you compare single value, just use double equal. If you compare with two values, just write something like this. Don't run it like that. Don't write it like this. This is wrong. Okay. All right. Let's move on to the last mistake that we'll talk about. Is possibility of no return. What does that mean? Okay. For example, I want to run a program that checks some value. Okay. Somewhere in my function, I want to check this value. So if this value is less than 100, I'll return the twice of it. Okay. So the flaw of this is that I have a possibility of no return. So what happens if the a is larger than 100? Nothing will be returned, right? So this is very dangerous. This is a logic flaw. So if it's check 3, then nothing will be returned. Yeah. So just bear in mind that if you put your return value in a if, or if you put your return command in a if, or if you want to put your return command in a switch, always remember to return something in the else or in the default. Else, return 0, something. Yeah, always return something. So this will complete your logic flow. Yeah, and this will guarantee that your function is guaranteed to return something. Okay. All right. So that are all the common mistakes that I'm going to talk about. Next, I'm going to talk about some good practice. Okay. So the first thing is always a good habit to wrap your statements. For example, firstly, after an if statement, for example, if you want to write if, right? So if something, then I will say print something else, print something else. Okay, so if you write it like this, you're not adding brackets after the if. So this is dangerous because in a later stage, if you want to add more commands after the if, you may forget that no brackets are added. So for example, in a later stage, if you want to debug, you want to say print some other value. Yeah, you want to debug. So you just add on and add on. So this is obviously wrong because you didn't add brackets after if. So only this first line belongs to the if. So a good practice is no matter how many lines after if, always add a bracket to make it safe and also make it easier to understand. Yeah. So even if just one line, I still want to add this. So later on, if I add something more, if I want to debug or if I want to extend the functions, yes, I'm always safe. Okay. Of course, in complex arithmetic expressions whereby there are too many operators, so it's always a good habit to wrap parentheses in the things you want to compute first. All right. So that's practice number 1. Moving on, indentation. Okay. So for example, I think this has been stressed. A lot in our lecture, but another thing you want to take note is, for example, if your if is too long, for example, it's like this, for loop, okay, for loop, and I got if as well. So it's good that you are indenting your code. However, have you noticed that there are too many levels down? So it's very difficult to track your code. So you use indentation, no problem, but with depth limit. So if you are realizing that you are actually indenting too much, you should try to extract some of the things to a new function. For example, I may want to extract these few lines to a new function. For example, I want to say, okay, so if this is the case, oops, yeah, I want to say compute tags. Okay, so I extract that for loop and many other in-depth indentations, right? I extract them to a new function. So in this case, it's more expressive and it's much clearer. Yeah. So indentation, good, but limits the depth. Moving on, the third practice is to play safe. Okay, so basically what I mean here is, for example, you have int compute tags, this function, right? And then you input a value, for example, input base. I want to compute the tags based on the base, right? So the precondition here, is base is always greater than 1,000. So I can assume that precondition base is always greater than 1,000. However, if I want to play safe, I can always go and check. Before I do anything, I want to go and check if base is less than or 1,000, is less than or equal to 1,000, then I will print wrong value of base. Okay, and then I will And then I will continue to do my computation. Yeah, so it's like before you proceed, you just check whether your input is valid. This is a good behavior. Yeah, it's a good habit because, for example, if you are writing your functions, writing the whole entire program with several other people, and this function is called by other people, the value is given by other people, it may not be safe all the time. Although you have agreed that the precondition is this, it's always good to check before you proceed. Okay, and what do I mean by return values? Before you return, right? For example, return computed text. Before you return, please check whether this computed text is whether it satisfies the precondition of the return value of entire this function. For example, here, notice here, if I want to, if we agree that compute text should return a text which is larger than, say, 500, then before I return, I go and check whether if whether if it satisfies my precondition that computing text is larger than the value we agreed on. So it's always safe. Of course, division by 0, whenever you do, let's say, A divided by B, okay? Before you proceed, always go and check if B not equal to 0, then I will do this, right? Else, I will print out some error. I will print out something to indicate that B is 0. Okay. So in this case, I am free. I will be. I'm safe from from making the mistake of division by 0. Okay. So moving on. Good practice number 4. Yeah. So let me just explain by examples. Go back to the main function. Okay, so let's say let's just focus on the first few lines, right? So let's say I want to there's an integer called a. Okay, so if a is if a is equal to 0, I do something. Oh, sorry, equal to 1. Else, if else, I do something else. Okay, so if you want to, so basically, what you are doing is you want to jump to a certain block based on the value of a, but in this case, if a equals to 1, go here. For every other condition, right, your program will jump to the other one, which is unsafe. For example, let's say gender. Okay, gender can be only 1 or 0. Okay, so if if gender equals to 1, male, else I'll say female. Okay, so in this case, this is unsafe because if the gender produced by previous steps is 3, which is invalid, right? For example, gender 3 is invalid. It will still go to here, but there's no way you can see that. So it's a good practice. You write another if gender equals to 0, then you will jump here. Okay? Else, print invalid value for gender. Okay, so the point is, if you want to use else to catch other cases, else it is better that else always catch exceptions. Okay, for this case, gender can be either 1 or 0. If it's 1, I do something. If 0, do something. If else is invalid, I do something else. Yeah, which is what I mean here. In if statement, else should always use to catch error. Similarly, for switch, you have many cases, case 1, case 0, and by default, okay, default means that thing doesn't satisfy any of those cases. So it's better to put the error log, the thing that can print out the error, at the default statement. Okay, in this case, it's safer. And if you made a mistake by generating the gender code, if you make any mistakes by generating the gender's value, it's very easy for you to spot that error. Okay. Moving on, practice number 5. Okay, you should return sensible values to caller, which means, for example, in this, let's look at these lines. We have a compute tags, right? So for example, I want to compute and print it. Compute and print text. Okay, so this is just an example. I want to compute and print out the text in that function. So it will be good if that thing can return you some value. For example, I've initialized variable called success. Okay, success equals to this. So after this function is computed, after the text is computed and is printed out, yes, but it will return me either 1 or 0, telling me that whether it's success or not. So that I can do something like, oops. If success, then I will do something to notify the user that I've succeeded, else I will do something else to notify the user that some error happened. Successfully computed and printed. Yeah. So let me just say it again. So compute and print text is compute and print, but after you print the text, it returns a success code, whether it's 1 or 0. Then depending on it's 1 or 0, you do something else. You do something further. Maybe if it's successful, you want to tell the user, oh, it's successfully printed, and maybe you want to proceed to many other functions. And if error occurs, maybe you want to restart the program, or you want to jump to another function. You want to call another function, right? So in this case, this function not only print the text, it also return a reasonable feedback to the function that calls it, so that the function can proceed based on the feedback, which is I mean here, return sensible values to the caller. Yeah, but don't complicate yourself. If this function is very, very simple and it doesn't have to return any value at all, you don't have to complicate yourself by doing this. Yeah. So whether to do it depends on you. Next is documentation. So it's a very, very good behavior that you can write documents in front of a function describing what the function does, and also in front of a series of logic flows to explain what is happening. Just one thing I want to highlight. Let's say this compute text, right? You should, when you do documents, yes, you can say the precondition, but what you should focus is what the function does and why it does it. Okay? So what the function does means what is the behavior of the function, what it changes, what it does, okay? And then why it does it. Why do you want to do that? Okay, you focus on these two. But don't focus on how. Don't say how this function does it. We don't care. Because people when people read this function, right, people are interested to know what it does and why it does it, so that people can make use of the function, right? For example, oh, this is to compute a text. And then it says what the function does is to compute a text based on certain algorithms. Then I can use this function directly. I don't want to know how it's implemented. So don't write how on the command here. Okay, is no need to document. Another reason of it is that the function, the details are already there. So if the user wants to know how, it can just read the code. Yeah. Okay. Moving on, good practice number 7, don't start your function name with underscore. It may conflict with compiler-generated identifier, means when a compiler is compiling your program, it will generate certain functions, certain names, starting with underscore. If your function happen to have the same name, then the compile will fail. Okay. Another thing is may conflict with library functions, which means the libraries that you have imported may also contain function names that starts with underscore. So always use names like these, compute tags, names like success, yeah. So don't use any name starting with this, starting with underscore. All right, moving on. Choose meaningful names for your functions and for your variables, and choose meaningful name. For example, add integer. So basically, there are two ways here. One way is to put every word together, but the first word is a small case, and subsequent words starting with uppercase. All right. Another way is we put underscore in between, and every word is small case. Which style to choose depending on you, but once you have chosen a certain style, stick with it, and throughout your program, right, you stick with this standard. Don't change from this standard to the other one. That will confuse the user. All right, and then related things should be named similarly. For example, in your lab exercise, okay, I just write here, right? I just write here. So in your lab, you have tray length and slab length. Yeah. So this is a very good naming convention, and you are naming similar things with similar names. If you go tray of length of tray slab length. You see, if you name it this way, although these two values belong to the same group of values, but they have completely different names. Completely different ways of naming. Yeah. So this is very confusing. Don't do that. Instead, do this. This is good. Yeah. Okay. And be accurate. For example, if you have something called process stuff, this function. Do you have any idea how bad this is? Process stuff is very blurred. For example, what is the stuff? What is the thing that you are going to process? And how are you going to process it? Process is very general. So if you say compute text, let's say compute text, that will be a good name, because the thing you want to do is compute. The thing you want to do it on is text. So compute text, be accurate. All right. Also mind your word form. For example, if the variable is, for example, if it's an array, right? It's an array that contains student marks. Then you should name it as marks instead of mark. Yeah. So if that's a collection, if it's an array, then use plural form. It's more intuitive for the one who read your program. Okay. And another thing I want to highlight is you should always use spaces in between. For example, place space on either side of an operator. For example, I have a space here, I have a space here, and here. So if I do it this way, everything is evenly spread out, and you can easily keep track of the flow of the function. Similarly, I have space here after the comma, here and here. Sorry, and here. Yeah. So this will make your program look very nice and very easy for the eye to read it. Okay. And then another one I want to highlight. We have seen this in discussion group session 1, which is on week 3. So print should be 1 per line. If you want to print multiple values, like okay, so on and so forth. This is not good, and this is discouraged from C programming, because if you happen to add extra spaces here or some other errors here, so it's very hard to keep track. Yeah. So in this case, you simply add several prints starting with each line. So each line you print, yeah, something. So each line includes only 1 print. Okay. Moving on, minimize duplication whenever you can. One good example is a max function. If you, let's say, okay, let's go down and get some more space. Let's say in your main function, right, you want to have a max comparison, then say A and B. You want to return the larger of the two. So if A less than B, okay. Okay, of course you have a max. Okay, max equals to B. Else max. Okay, I'm sorry about the typo. Max equals to A. Okay. So in your main function, if you want to compare, return the larger one, you do this. And somewhere else in your main function, you also want to compare C and D. What you do is you write the function there again. You want to compare int max, okay? Max. Maybe you'll name it in max2. If blah blah blah, you do it again. So as you can see, this is very bad because you're repeating yourself here and here. It's better if you just define a function named max. It takes in 2 integers and return the bigger one. So whenever you want to compare 2 values, you just call the function. So in this way, if you make a mistake in the max function, you just change 1 instance instead of changing everything. Okay? Yeah. Lastly, we have a way of presenting your program better. Let's just compare these two. So this is the first way of writing my program. I scan some basic, maybe basic integer, and then I compute the salary, compute the tax, and print it out. Versus this version. Okay, I read the input, I calculate salary, calculate tax, and display result. So this manner is more readable, and actually you are actually telling a story, telling how your workflow should go, and it's very intuitive to understand. Yeah. So especially when these lines are infinitely long. For example, scanf, you want to scanf multiple values. For salary, you have a very complicated formula. Tax as well, you have a very long arithmetic expressions. If you write it this way, it will be very long and messy. Every detail is here, and it will confuse the user. In that case, it's better if you can extract all these into 4 functions with names with very easy to understand names on top as the function names here. Yeah. So write a program like this, you're telling a story, it's very easy to understand. All right, that's all about today's session. Common mistakes and good practice. Hope you have learned something and hope you can apply them to your coding in the future. Okay? Have a nice weekend. See you next week. Thank you for watching. Thank you. Bye-bye.